The distance of the tide on a beach can be modelled by the following equation, where d is the distance in metres from the sand dunes and t is the time in hours after 9 am. So the equation is d of t is equal to negative 10 cos of pi t divided by 6 plus 10. For part A, we are asked to graph the function d of t over the interval t is an element of 0 to 24 included. Clearly label all axial intercepts, endpoints, maximums and minimums with their coordinates. On the CAS calculator, go into the main menu. Before we go too far into this, just check that the settings are correct. So for this question, we want our calculator set into radians. Next, we want to type in our equation d of t. So we have negative 10 times cos, and then it's pi, and we're going to replace t with x for the calculator, divided by 6. Close the bracket, and plus 10. Just to make our life a little bit easier, I'm going to define this. So we go interactive and define. And using the ABC keyboard, I can actually call it d of x. So that's properly defined now. And what we want to do to start off with is graph this. So if I hit the graph icon, it brings up this screen, and I can drag d of t down, and that will sketch the graph. Now we want to change our view screen, so we want to graph it from perhaps x is negative 2 through to x is 26, so just a little bit further than what we need to graph it over. And then for the y values, I'm going to graph it between negative 5 and the amplitude is 10 and the mean value of the function is 10, so it goes up as high as 20. So I'm going to go to about 25, so I have a bit of extra room on my graph. Hitting OK shows me this graph. And I can now use analysis gsolve to find key features. So to start with, I'm going to find the minimums, which are also x-intercepts. So there's one at 0, 0. And if I hit execute, it will lock onto the screen. Pressing the right arrow will take me to 12, 0. Again, hitting execute will lock it on. And then hitting right one more time will find the last value that's at 24. And hitting execute will lock that on. Next, we can use analysis gsolve max to find the two maximums that are at 620, and if we tab across, the other one's at 1820, and hitting execute locks those points on. So from the CAS calculator, we can see that our graph has this shape. And then we used the analysis gsolve tools to find that this point was 0, 0. This point here was at 12, 0, and the end point was at 24, 0. These were also the minimums of our graph, and our maximums occurred halfway between those at 6, 20 and at 18, 20. Next, we're instructed that high tide occurs when the water reaches the sand dunes, and that the low tide is when the water is furthest from the sand dunes. For part B, we're asked at what times does the high tide occur? So keeping in mind that high tide occurs when the water reaches the sand dunes, that means the distance from the sand dunes is going to equal 0. So what we want to find is when d of t equals 0 over our domain that x is an element of 0 to 24. So we can use the calculator to solve d of x is equal to 0, so I can drag d of x down and put equals 0. And rather than get lots and lots of solutions or a general solution, I'm going to restrict the domain using math 3 and this straight up and down line. So I can put x is between 0, so x is greater than or equal to 0, but less than or equal to 24, and that will only find the solutions over that domain. Highlighting that, we can go interactive, equation inequality, solve for x, and they are the three solutions that give d of x equal to 0. So if we hide the keyboard, these are the same solutions at 0, 0, 12, 0, and 24, 0 that were on the graph before. So from the calculator, we find that t equals 0, t equals 12, and t equals 24 are the three values of t over our domain that satisfy the equation d of t equals 0, which is when high tide occurs. So to complete question B, we're asked for the times, so we need to convert these into times, and we need to remember that t is the time in hours after 9 am. So t equals 0 is in fact 9 o'clock am. 12 hours after that at t equals 12 is going to be 9 o'clock pm, and t equals 24 is going to be 9 o'clock am again, but it's going to be the next day. So these are the three times when we have a high tide occurring. For part C, we're asked at what times does low tide occur. So this time we're solving d of t is equal to the furthest y value away from the sand dunes. So we're asked to solve d of t is equal to 20. Next, we want to solve d of x is equal to 20 over the same domain. So to save time, I can actually drag down this entire line and just change my 0 into 20 and hit execute. And that gives me x is 6 and x equals 18 as solutions, which are the same as the maximums that we found on the graph. And we find that t equals 6 and t equals 18 are the two solutions within the domain t is an element of 0 to 24. Once again, we're asked for the times. So t equals 6 is 6 hours after 9 a.m. and that's going to be at 3 p.m. And t equals 18 is going to be at 3 a.m., but that is going to be the following day. So they are the two times when we have low tide occurring over our domain. Sam decides to build a sandcastle 16 metres from the sand dunes. What is the earliest time after t equals 0 that Sam can start building his castle? Give your answer correct to the nearest minute. So if Sam wants to build his castle 16 metres from the sand dunes, then we want to solve d of t is equal to 16. Once again, we want to solve an equation, so I'm going to drag the whole line down just to save time. And this time we're solving d of x is equal to 16 over the domain of our function. Hitting execute gives us these two solutions, and the question asks for decimals, so I can change it over. And the one that we're interested in is this x is equal to 4.229, correct to 3 decimal places. We can also find that same solution on the graph by going analysis, gsolve, and we can do an x calculate and ask it for a y value of 16. So hitting OK gives us 4.229, and I'll just hit execute to lock that onto the graph. Therefore, from the CAS calculator, we find that t is equal to 4.229, correct to 3 decimal places. However, once again, we need to read the question to make sure we answer it. So we're asked for the time. So instead of a number of hours, we need to convert this into a time. As we're asked for a time, and we've currently got it as hours in a decimal, we can drag that down to the next line, highlight it, and go interactive transformation. And DMS is degrees, minutes, seconds, which is the same conversion we use for hours, minutes, and seconds. So if we want to go to DMS, that will convert it to 4 hours, 13 minutes. And going to a decimal, this is 44.4 seconds. So it's close to 4 hours and 14 minutes. And now that we've used our calculator to convert it into hours, minutes, and seconds, we can now say that we start at 9 a.m. and then we need to add on 4 hours and 14 minutes, and that will give Sam a starting time of 1:14 p.m. So that is the earliest time he could start building this castle. For part E, it says if it takes Sam 45 minutes to build the castle, how long will it remain standing, fully finished, before the tide reaches it again? Give your answer correct to 2 decimal places. So from the calculator we can see that d of t equals 16 gives us t equals 4.229, which we already had above, and the next time is when t is equal to 7.771. We can also find that point on the graph screen by going analysis and again going gsolve, and we want to do an x calculate based on a y value of 16. Hitting execute finds the first one again, and tabbing across we'll find the next value at 7.771. Now to find the time that will remain standing fully finished, we can take 7.771 and subtract off 4.229, and we also want to subtract off from that the 45 minutes that it takes for him to build it, which is 0.75 of an hour. So if we evaluate that, we find that the castle will remain standing for 2.79 hours, correct to 2 decimal places. So just to explain that, we have Sam starting to build his castle here. The tide then travels further away and then comes backwards and hits the castle, and that means that he would expect it to stand fully finished for 2.79 hours.